Of the VMware Code Power Sessions. In this particular session, we're going to be talking about turning your organization's policies into code for compliance at scale. My name is Kyle Ruddy. I do work at HashiCorp, although I have a brief slide about me a little later on. Diving directly into the agenda, we're going to do a brief level set on what Terraform actually is. Then we're going to dive into some of the ideas and concepts around policy as code, the foundational policies library, and then we're going to have tons of demos. So definitely stick around for the demo part. All right, quick Terraform overview. So, kind of before we get to the what, let's start taking a look at part of the why. So if you think about it, for at least myself in my career, I've been interacting with what's known as static infrastructure. We had been deploying hardware on a 5-year basis. We even deployed some virtual machines, and they basically lived for the entire life cycle of the hardware itself. Sometimes we had the occasional maintenance window. Unfortunately, not all of them were planned. Some of those, hair on fire Sev1 outages, unfortunately, did sneak into the mix there. But the key here is how we did it. And a lot of it was through a lot of manual work. So, me and some of my former teams, we would try and automate as much as possible. Filling up repositories full of PowerShell and Python scripts. And then really at a certain point in time, cloud kind of entered into this picture. And so now some of these teams that I were on were asked to be more dynamic, being able to support the deployment of any workload to whatever cloud, whether this being on-premises clouds, AWS, Azure, pretty much everything across the board. And, it was getting to the point where it was also scaling up. So these workloads were being deployed not like on a individual case-by-case basis. We're talking, tens of workloads that needed to be provisioned, hundreds of workloads that needed to be provisioned. And there was really no time to really wait on, people to work through the ticket queue or to go through, the IT process there. So when it comes to, kind of the HashiCorp side of thinking, we kind of break it down into these 4 different pillars that work into 4 different kinds of people on the IT side to really figure out how to operate in this dynamic infrastructure. And these also pretty much align to our product lines as well. But in this particular session, we're focusing on Terraform, which is used to provision and manage your infrastructure declaratively through code. Most everybody knows this as infrastructure as code. All right, so some of the use cases that come up most frequently, just being able to sit there and being able to declare our infrastructure, the things that we are consuming through our environment as code. Being able to basically blueprint it all out so that we have an understanding of what's there, how it's configured, and being able to go back through and look at this documentation. Then we get to a point where we can share this out amongst our team. So it's not just a single person that's kind of, jack of all trades, particularly for this one piece of infrastructure. It's across all of our teams. Then we get into multi-cloud. This is where we go from on-premises private clouds to hybrid cloud, integrating some of those other, the managed cloud services that are out there to, just public cloud. And then lastly, the big one is around self-service infrastructure, where, this is kind of taking the IT side of it out of it so that the people who needs to consume the workloads themselves are able to go out there, request them, and gain access to them. All right, so it can't be a Terraform session without actually talking about Terraform. And I will, but kind of. So let's talk Terraform and some of the updates that are coming there. So, one of the really cool new things that is coming out is Terraform 0.13. This is something that's out in release candidate 1. We are targeting a fully GA release at, part of early August. And what we're doing with this is, we've kind of changed the mentality. If for those who know a lot about Terraform and have used it for several years, 0.12 was a major release. Like there were rewrites, there were all these considerations and things along those lines. 0.13 comes along, there's a couple new additions, but it's basically about stability. Now, some of those new features are around adding functionalities to modules, being able to parameterize the uses of count, for each, and depends on to fill in some of the gaps that maybe Terraform doesn't already cover today. Now, we also have some new integrations within Terraform Cloud, being able to do just a Terraform login. It walks you through the authentication process to Terraform Cloud, and boom, your API token is stored locally and you're all set to go. There's no further configuration needed to manage that remote state, either however you run your Terraform plans and applies, or where you're storing your remote state. And then lastly, some updated support for the Terraform registry. The Terraform registry is getting all kinds of new features. There are the HashiCorp providers that are out there. There are partner providers, and there are also some community providers that are out there. And Terraform 0.13 helps you really kind of be able to specify exactly which provider you're looking to use. A couple of new updates for Terraform Cloud Enterprise as well. I'll cover these really quick. First and foremost, there's a getting started walkthrough. If you've never used Terraform Cloud, which I'll show you a little bit of how that works as part of our demos, it walks you through how to get your environment set up to run. There are also what's known as run triggers. This is the ability to take the notion of Terraform workspaces and being able to integrate these workspaces in between each other. So, think of it kind of like a software development process, where when this workspace runs and it finishes, it triggers a completely other workspace to then go through and perform its tasks as well. Really, the goal here is just create and provide more reusable portions of code. And then also some tremendous updates to user management. All right, so let's get into policy as code and really what this session is here to talk about. So, if you have this understanding of what infrastructure as code is, and you're able to deploy through your resources, your infrastructure, your workloads, all of these things that you're working to consume, what happens from that point? Like, how do we take some of these organizational policies that are out there? Like, think of it like, when can you deploy things? At what size can some of these instances be? And who has access to them? How are those things being treated within your infrastructure as code environment? So basically, how do we provide that kind of consistency that maybe your standard traditional environment has compared to your infrastructure as code environment? So it kind of breaks down into a couple different areas here. The first one being embed. So, you're taking some of those organizational best practices. These are things that your individual organization has defined and should be used throughout all your environments. Things such as enabling tags, or restricting, who can use what certain particular instance type, and ensuring that there are time to live variables, making sure that some of those resources that have been deployed don't live, well beyond its necessary time frame. Then there's also enforcement. So getting more into the policy side of things and security. So, instead of, embedding tags into them, we're now checking, verifying that our infrastructure does have those tags that have been configured. Perhaps making sure that different environments, such as your development or staging or production environments, are using their own individual properly sized instances. And likewise for when they're deployed themselves. Nobody wants a development environment that runs overnight if nobody's actually going to be using it. That's just not a good use of resources. As well as being able to control some of those costs. A lot of the public clouds and other cloud resources have costs that are associated with them now that some of these folks that are moving to a cloud-based model now have to consider. And then there's also viewing, being able to have a consistent view across the entire environment, making sure that all of your, perhaps AWS EC2 instances are the same type. Or maybe if you're using VMware Cloud on AWS, making sure that all of your host sizes are the same size, that you don't have any misconfigurations there. Being able to embed or view like what infrastructure costs are happening throughout the environment, as well as being able to break it down into individual workloads, so you know how much an application deployment might actually cost, or how that would look throughout its life cycle. All right, so let's talk about embedding some of the best practices here. So Terraform has this notion of being able to write code, write your infrastructure as code, but then we also have what's known as the private module registry, where you can take some of these best practices or environmental best practices, basically, from your organization, and predefine them as part of a private module. This is very similar to what happens if you grab down a particular provider, and then you have to fill out all of those parameters to create some type of infrastructure. Well, you can take that provider, turn it into a module with some of those parameters already pre-filled in, which follow your corporation's best practices. We can also validate that those modules are pre-approved, that they're ready for release, so that anybody within the organization who has Terraform access can make use of them. And then we can publish those out to a library, and that's where everybody makes use of them. Then we have some enforcement, and this comes down to this notion of policy as code. Being able to basically put a trigger something at the end of a Terraform plan process or operation, and being able to check what's actually happening, or what type of infrastructure is going to be deployed, so that we kind of can wrap around some policies and rules and restrictions around what type of infrastructure are going to be deployed, making sure that those are following some of the best practices and pre-approval of policies, trying to limit like maybe use of a change control board, having some things pre-approved so we're good to go, and just streamline the entire process. And then we can publish those out and make sure that different workspaces have those automatically associated with them. Again, goal here, streamlining the entire process. And then lastly, we get to our view, being able to see across the board what our environments look like, what infrastructure has been provisioned, and kind of have an understanding or a notion of the costs associated with each and every single one of those parts and pieces. All right, so last thing before we dive into demos, I want to talk about the Terraform Foundational Policies Library. Now, when a lot of people get started using Sentinel and policy as code, it's a little overwhelming. So what HashiCorp has done has released this foundational policies library. It's out there on GitHub underneath the HashiCorp organization, and it comes pre-populated with about 50 different policies that are focused on the Center for Internet Security benchmarks. So it's targeting things such as compute or databases, Kubernetes, storage, networking, all these different things, to apply these industry standards that have already been declared by CIS. And at this point in time, it's covering those major cloud providers, the AWS, Azure, and GCP. All right, so done a lot of talking. I ran through that really quick because I do want to focus more on the demo side than anything else. So let's take a look at some of the use cases that we're working on here. So first and foremost, like, how do we understand or see the costs that are associated with our infrastructure? Then how do we take some of our organization best practices and apply them through policy as code? How do we start detecting some of these inconsistent infrastructure configurations? And then how do we make use of that Terraform Foundational Policies library with our infrastructure today? All right, so let's see if I can swap out. There we go. Okay, so our first demonstration, we're looking at a just a very basic website deployment. So we have a bunch of resources that are going to be deployed directly to AWS. Like we're creating a VPC as defined on line 7 here. We're creating an internet gateway, setting up some routing, subnets, so on and so forth. Like for the purpose of this demonstration, we don't really need to know what this is doing, although this is available out on my GitHub repository, which I'll have a link to later. The more important part here is how we manage or how we really start approaching that enforcement piece. So what we have is Sentinel, this policy as code type engine, and we have a couple policies that I'll get into later, but I'll show you how it works first, how we can get this set up. So here's our Terraform Cloud instance. Either Terraform Cloud or Terraform Enterprise is one of the requirements that you will need in order to make use of Sentinel and policy as code. So what we're going to do is we're going to start off by creating a workspace. This also has a nice handy walkthrough to kind of walk you along the process. We're going to go through GitHub to set up our connection to our repo there. There we go. And we're going to create our website, or our workspace rather. So while that is going, I'm going to go through and do some behind the scenes magic to set it up. There we go. Okay, so now that we should have some variables here. I've tossed in a public key, which is a requirement of our website configuration. We have our AWS region, which I set up for with a default of US West 2. Then we have our access key ID and secret access key itself. So theoretically, we're ready to deploy this. So we can just hit our Q plan button up there. This is doing the exact same thing as a Terraform plan. So we're going to be able to see the output from our plan operation here. It's going to tell us that it's creating a bunch of resources. And then it's going to start going through and hitting the cost estimation piece of it so that we kind of have an understanding of what this website is going to cost us. So our plan just wrapped up. It says that we're going to be adding 9 new resources. If we scroll through here, it'll show us exactly what we're creating that we walked through before in our Visual Studio Code, ISE. Then we can check out our cost estimation here. So as part of this, let me close up some of these additional pieces here real quick. It's costing on 2 different areas. First is our load balancer, which is saying that it's going to cost about 2.5 cents per hour for a monthly cost of $18. And as well as our AWS instance that's down here, it's going to be about the same cost, ending up being a monthly cost of about $16.50. So now we know that this website itself is going to cost about $34.56 on a monthly basis, as written here. Then we have our policy checks down here. So this is where we transition from our costing portion to more of our enforcement side. So we have 3 different policies that are here, which I'll go through here in just a second. Our first one is AWS costing. Then we have AWS time and AWS instance type. These are just some simple rules that I tossed together to kind of show the effectiveness of what Sentinel and policy as code can really do. Let me move my Zoom controls here. So here's our first policy here. It's looking at AWS costing. Right here is checking to see if the proposed monthly cost is less than $10. Now, we can see from above, it's going to be $18 just for the load balancer, so that's never going to pass. However, we have set that to a particular level, a security level, where we can override that. So it's just an advisory failed. It's not a hard failure. Then our next one, it's looking here. Policy 2 is looking at our AWS instance type. So it's checking to make sure that we are using a T2.micro instance type from AWS. It sees that, let's see. Yeah, I think I have an error in my logic there. So ignore that part for right now. But our last piece down here, our policy number 3, is AWS time. So basically, this is just checking to make sure that it's not Friday, because read-only Friday is a thing that we all should abide by because we all want to enjoy our own weekends. So in this case, the instance type failed, so the entire thing fails because we're not using the appropriate instance type. So what we're going to do now is kind of take this to the next level. So we have, some fairly basic things that are here. But now, what happens if we have a development environment as well as a production environment? I'm going to do some more behind-the-scenes magic here to set all that up, and then we'll go check out our Sentinel policies there. Okay, so that should be running. So taking a brief look at some of these, here's our first one. So Sentinel policies are basically, when you whittle it all down, it's a true or false test. It's Boolean. Does it pass or does it fail? If it fails, we go back to our advisory level. So in this case, we're checking to see if our Terraform run has a cost estimate with a proposed monthly cost that is less than 10. So we can choose that to be whatever we want to. We can put it into Terraform that this is a variable, so it's not just a static value that's included into our rule here. We can do all kinds of things. Sentinel, underneath the covers is its own language. And I should also point out while we're here, Sentinel also has its own plugin or extension for Visual Studio Code. So it can kind of help you out with some of the logic and ideas and concepts there. Then going over to our instance type, this is going to be for our next one. So we're looking at a difference between our production environment and our development environment, because we want to follow those best practices where our development environment doesn't need perhaps a T2.large. Maybe it only needs a T2.micro. So, a little bit of cost savings, a little bit of effectiveness in that area versus prod, where we wanted to have that performance available all the time. So we have some basic if-else statements down here, checking to see what our workspace name is, and if our workspace name is basic site prod or basic site dev, that's what it aligns our instance mapping to above, which creates our configured instance down here, just saying, again, pulling from our Terraform plan, from our module, looking at our resources, then our AWS instance for our web resource. It's going to look at the instance type, pulls that out, makes the comparison to our mapping that's located up above that, and we end up with a true false. Now, the last one is our timing. This is very simple. This is not in any way, shape, or form AWS related. We can apply this to any infrastructure, any Terraform infrastructure configuration code. And basically what this is doing, it's using a time resource, importing that in, pulling out what the weekday is. The weekday is a value, is a numeric value, and then 5 is the number that's associated with Friday. So as long as the work day, or rather weekday, is not equal to 5, it's going to go ahead. So now that our other workspaces should be set up, we should be able to go back to here. So now we have 2 new workspaces that are set up. We have a dev and a prod that matches that Sentinel policy that I was just referring to. Again, we have our variables all configured. Everything looks very similar to what we had before. The only big difference, which I think I can call out here, let's see, version control. So in this case, we are separating out our different workspaces by individual branches. So we have a branch for prod and we have a branch for dev. Terraform Cloud right now is looking at that prod branch. So we can queue up our Terraform plan. It's going to go ahead and roll through, very similarly to our last, just the demo environment from before. So it should end up creating about 9 different instances, but the cost is going to change. It's going to look a little different than it did before. So there we have our plan, our output there, just saying, again, we're adding 9 new things. And then our cost estimation is going to roll out. And see, there's a little bit of a difference here, when it comes to production, because we're maybe using a larger instance than we were before. So instead of that, 2.5-ish cents per hour, we're looking at 37 cents per hour, which actually, extends up through, and, we're looking at $267 for a total of $285 per month, just to run this individual website as it's been declared. So going back up through our different policies here, you can see that our costing, that one is still set to 10. So this is definitely going to fail. This is never going to pass. So no worries there. But then our instance type here, this is where it catches something interesting. So we saw our policy before, we were looking for that t2.large instance type. But in this particular case, we should be able to look up back at our infrastructure, our plan output, and see that it's looking for a t2.2 extra large, which is above and beyond what it's supposed to be looking for. So we caught something right there, so we can establish some consistency throughout our environments. And then lastly, it's Thursday, or no, it's Tuesday where I'm at. So again, we're good on the Friday piece. So let's take a look up top through our plan and make sure that that is indeed what it was looking for. We can see our instance type right here, that is planned to be created, and it is t2.2xl. So again, hit that, failed, not going to be allowed. Okay, so this isn't the only thing that we can do here. AWS, we can do all kinds of other things as well. So let's switch gears a little bit and take a look at perhaps an Azure environment. Let me clean up my stuff here and get our new environment stood up. So I can close out of this one if it'll let me. Yeah. Okay, so here's our Azure environment here. We're using the RM provider that's up there. Then we're going to be creating some things, such as a resource group, some managed disks, virtual networks, subnets. We're standing up a very similar website to what we had in our previous demo, just in a different public cloud resource. So we have, very similarly to the last one, we have our sentinel.hcl, which is defining what policies should be enabled and checked against this environment. So we have instance type and time. Our time is up there. It just says, again, very same thing. Let me open up where is my instance type? Let me open up the instance type one here real quick, because this is very similar as well. So, this time we're looking for a standard _D2. We're going to pull out our workspace name from here, and then we're using the Terraform plan, pulling out our module, looking at our resources, and particularly the Azure RM virtual machine. And then we've defined it internally. We've given that virtual machine a name, that resource a name of cat app, and we are looking for the VM size. Then down here at the bottom, we're comparing those two. Does our configured VM size, how does that compare to our desired VM size? And that, again, is going to end in a true or false statement in the end. So let's go back to our Terraform Cloud instance. We now have a HashiCat-Azure. This is, again, something that's out there in the GitHub repository. So if you're trying to follow along, all of these things will be available after the fact. A couple of the variables that I've set up that have been defined in there. Although, let's go ahead and edit our value for our prefix here and say VMware code. So we'll save that variable there. And let's queue up our plan. So, this is doing the exact same thing as what you would do locally with the Terraform plan. It's just going to go through, churn out exactly what it takes to create this environment as we've declared it in that configuration file that I was showing. We have 9 things that we want to add. See, very similar to our AWS configuration there. Then we run through the cost estimation. However, I believe my environment is still not so happy with doing cost estimation for Azure, so it's probably going to fail out. This is a me problem, my organization problem, not a everyone else problem. Yeah, there we go. Okay, yeah, something went wrong. Yes, I'm sorry about that. And then we get to our policies here. So we have our tool rules that I walked through before. Checking to make sure that our instance type match the standard D2 VM size. So we're all set on that one. And then again, it's not Friday. Today is Tuesday, so we're set. So we can go down here. We can tell it to confirm. We're ready to apply and create our Azure instances to stand up this website that lets us look at miscellaneous pictures of cats. However, this is where we want to start taking a look at maybe getting a little more security conscience, starting to take a look at some of the industry standards, such as the Center for Internet Security, or CIS benchmarks. So we're going to discard this run. I'm not going to add a comment just in for the sake of time here. And we're going to go through to our settings. We can go to policy sets. Here we can see some of those policy sets that I'm pointing to. In this case, I'm pointing to policies-Azure. But we want to take a look at our foundational policies library. So if we click on that, it'll take us out to the GitHub repository, which let me adjust my zoom there. So here is the Terraform foundational policies library. As I mentioned before, this is just a library that has a bunch of pre-populated Sentinel rules that follow along with some of the industry best practices. In this case, we've started off with CIS, so we can see that there is a CIS folder. And then we can see that we have some stuff for AWS, for Azure, and GCP. Since we're working with Azure, we'll click into that. Then we have compute, databases, networking, and storage. We're working with compute resources right now, so we're going to take a look at that. So we have 7.1 and 7.4. These are what's been configured within the CIS benchmark that literally lines up to what they've created. And we can, for this instance, 7.1 is aligned up to making sure that all of the managed disks are encrypted. Very security conscious, making sure that we are enforcing that, as well as making sure that only the approved extensions are being installed for this environment. Now, instead of having to, clone or copy down this repository, we can make use of this source parameter. Source allows us to go out, point to anything that is in a .sentinel extension there, and use that rule as it's been defined. But for the sake of this demonstration, we can copy out our configuration as it's shown right there. Go to our sentinel.hcl file that's right here. This is our policy set. And then we can just paste that in. Now, we want to make sure that everything is being encrypted, managed disk-wise. So we're going to update this to be hard mandatory as well. Now we also can input our other one that's over here about our approved extensions just by copying that very similarly and pasting that down below. So we will save our file right there. Then we head on over to our Git integration here within Visual Studio Code. We want to add our changes there. We'll add in some, saying updating for foundational policies usage, something along those lines. I just did a commit. And from that point, we are ready to push this on directly out to our repository, our GitHub repository. Moving back over here, we can go back through to our workspaces, go back to HashiCat, and queue up our plan again. Similarly to the last time, our plan is going to run through, show us what it's going to take to create all of those objects within the desired cloud instance. It's going to be 9 again, since we haven't been modifying the infrastructure itself. Then it does cost, and then it does our policy check again. There we go. So our plan wrapped up. We can see that we still have those 9 resources to add to make this complete. Cost estimation is going to give us a warning again. And then here's our policy check. So we've gone through here. We have our Azure instance type and our Azure time that was that I kind of walked through those policies earlier. Those are still passing. However, here's the surprise. We apparently have a managed disk with encryption that is disabled. So all of a sudden, this is a very easy way to take some of those CIS benchmarks, apply it to our infrastructure as it's already been defined, and really detect some things that that maybe should have been caught before. So it pops out an error, has some extremely nice details that are in here. Let me scroll up to where it is. So we can see exactly at which point it went through and actually failed. Then we can go down to our CIS 7.4 and see the extensions that are being installed and making sure that they are all of the approved status, in which case that one is good. And since our disk encryption was set to, or was rather not set to enabled for the encryption, it failed the entire process. So we cannot continue down the path of deploying this environment. All right, so that was a quick walkthrough of kind of how we can use Sentinel and policy as code amongst cost estimation to really find out some new things about our environment that maybe we didn't know how to see or get a hold of before. So we were able to use cost estimation to see how much, just say, a regular infrastructure deployment was going to be. We could see how much a development versus a production environment was going to be. And kind of have a really good understanding of what that application or what that workload takes to run on both an hourly as well as a monthly basis. Then we had our Sentinel and our policy as code configuration there, so that we could take a look at some of those costing limits, making sure that we didn't spend above $10 a month, or being able to follow some of those best practices to ensure our different instance types were following amongst our development versus production branches. We were following things such as, don't deploy on Friday because, I'm a big believer in, trying to limit the amount of work that we do on the weekend, making sure that our infrastructure is uniform across all of our instance types. And then, the surprise of applying some of those Center for Internet Security benchmarks to ensure that our, make sure that we're following those policies. And in our use case in this demo, it was finding out that, surprise, one of our disks was not actually being encrypted. So a couple things to follow up on afterwards. Check out the Terraform GitHub repository. There is the release candidate 1 version of Terraform 0.13 that's out there available for download to start using and start making use of some of those new functionalities and stability improvements. Check out Terraform Cloud, extremely easy to get started with, great location to store your remote state. As well as being able to do some of those remote operations without having to tie up your local machine. And then getting started with Sentinel and policy as code, especially through the foundational policies library. And there are a lot of other Sentinel resources that are out there that you can make use of as well. So instead of having to start from scratch, use the community, use other folks out there in the ecosystem to kind of learn and grasp some of that knowledge that's already been laid out. A little bit about me. My name is Kyle Ruddy. I'm in technical marketing at HashiCorp, focusing specifically on Terraform. Twitter is probably the easiest way to reach out and get a hold of me. Twitter DMs are the thing that gets my attention first. All of the code that we've seen today is available on my GitHub repository, as most of them were forks from other locations, so you can kind of follow that back to the original source. I'm also out there on LinkedIn. If you're not a Twitter user, hit me up on LinkedIn. So with that, any questions, any comments, any things along that line? I don't know that I've seen too many things come in so far. Nothing new from Kripa. So with that, thank you very much for hanging out for the last 45 minutes. And definitely hit me up if you have questions, comments, or want to talk infrastructure as code. Thank you.